I know the moment I have to go backward case. How much plastic is that? If you know the load there. And we go backward. So we have done that forward case, backward case. Correct?
Yes.
So that is the loading part. Look at the loading part. The cross section we understand already. What about the loading part? So if the beam like that, so we have the moment like that. Is that correct?
Yes, correct.
If the loading is distributed load, we don't know the value. Let's say the W there. So how's the bending part? Remember the cross section? Let's say this is 2 meter there. It's 1 meter, 1 meter. What do we have there? The total weight is 2 omega. 1 omega, 1 omega. 1 omega up, constant, and then going down, and then constant. So that's the V, right?
Yes.
You must be very quick on this. And then what's the moment? You go up there, and then from here to here, going up, and then from here to here, going down, curve, and then from here to here, it's going straight. Still remember this one?
Still remember.
So this is curve now. It's not a straight line anymore, if that is that one. And then you relate back, this is the moment here. What's the moment there? The moment is, let's say, 2.5p, whatever it is. Let's say. Sometimes 0.4p. I don't know. Can be anything. So if that is 0.5, 4.4 feet, what is that? What is that? What is that? You can find that on the graph. Are you with me?
Yes.
So what are the other loading? If the loading is like that, this is all solid one, static. I want to bend it like that. I climb it there, and then I put a load there. So what happened here? The thing will be bent like that, right? Are you with me?
Yes, doctor, I realized that we haven't do the backward case. We just given top surface plastic, and find the bottom part, how many thickness of the plastic.
That is backward.
Call backward lah. Even.
That is backward.
Oh, okay.
You don't know the thickness, right? Only after that you find the. You are given the moment. How much plastic? That is backward.
We are given top surface plastic.
Yeah, that's the meaning. When you know the top surface plastic, that is moment, right?
Yes.
You're given the moment there.
Oh,
In other words, you are given the moment.
Understood.
Are you with me not?
Yes, understood.
Let's say we have here. So forget about this. Let's do this one first. This is also bending not?
Yes.
So why that moment diagram? Moment diagram is like that, right? Maximum is here, right?
Yes.
The moment diagram is that zero moment here and maximum moment. So maybe the start of plastic there, and then fully plastic there, or separa plastic there. So start of plastic there. So if you draw that before the bending, so maybe separa plastic there and then something like that. Just halfway of that. The diagram is like that. Can you see that?
Yes.
If let's say you put a distributed load, see the same diagram not?
Yes.
Yes. Only the graph is not there. It's straight line there and then a curve there. Something like that. Right?
Yes.
So all these things you have to train yourself. But at the end here, it's all about moment that value. That moment here relate with the cross section. Are you with me, guys?
Yes.
Okay. Now look at this. This one, is it the same with this? The same not?
Yes, it's the same.
It's the same. All are unsymmetry. If I don't do this, I put like that. The same not?
Yes.
It's the same also. You must realize this, all these sort of things. Okay? So, you say we haven't done the backward case. Okay, let's do this. I put this 1000 Newton. 1000 Newton. Let's say the cross section is like that. For moment maximum elastic, let's say this one is 10 kilonewton meter. So when I put this load here, whatever x here, let's say when you do the moment there, let's say the moment here now is 12 kilonewton meter. With that distance, right? Let's say the value is 12 kilonewton meter. Let's say. Now it is higher than moment elastic, not?
Yes.
So can I find this diagram now?
Can.
And this is what? Backward? Are you with me?
Yes.
This is what I call backward. So I can find how much thickness with 12 that one. So what do? I don't know the height. I don't know the height that one. I don't know the E. I don't know the E. Let's say the height here is 50. This is 50 minus E. So this is 50 minus E. So this is 100. This is 50. Let's say this is 40. E 50 minus E. So the diagram must be like that. Are you with me there?
Yes.
So I have my F1, I have my F2, all in terms of E, right?
Yes.
I have my F3, I have my 4. So my moment separa plastic is equal to F1 plus D1 plus F2 times D2 plus F3 times D3 plus F4 times D4. So all in terms of E. And this is equal to what? 12 kilonewton. Can I find my E?
Can.
So this is what I call reverse. You have done that actually. Okay?
Okay.
This is what I call reverse. When I know how much cross section, you go back how much load. If you know the load, go back, you can find how much thickness become plastic. That's backward and forward. So always do this in other subject. The forward case, backward case. Make yourself understand the whole process. Are you with me, guys?
Understand?
Okay. So this is the conclusion of this subject. Can we conclude now? Okay? For your revision, look at the exercise that we have done. And you must do this forward, backward case on your own. Create your own question, a simple question like that, and calculate and do a forward, backward case. Are you with me, guys?
Yes, doctor.
I've teach you how to do the forward, backward case. Let's say, how to do that on your own. You create on your own question. And then you can confident what is going on. For example, I have to find this P for that to create that starting of plastic. Starting of plastic is like that, the diagram. Right? Starting of plastic is just one layer plastic, right?
Yes.
So, I know that starting of plastic, the moment I calculate is 10 kilonewton meter. From that 10, can I find my P?
Can.
Let's say my P is 5 kilonewton. So you know that that is starting of plastic. And then you do your own backward. How's that? You create your own question. What if I put this one 6 kilonewton? What happened? This might be separa plastic. So the separa plastic, can I find my thickness? So you have done the forward case, you have done the backward case. This is what I call you do on your own. Are you with me?
Yes.
Not by my question. My question is just halfway. You create, you evolve from that. You start on your own doing that work. And this is what I call, you create your independence in learning. You double check yourself, you double check your understanding, you confirm your understanding, you conclude your understanding. Are you with me?
Yes.
This is what most I want from you. Not just reading the solution and finish. Reading the solution and copy it back into that one for the test. That will not develop your thinking. I'm here this semester only. I will meet you this last time. I won't meet you again next semester until you graduate. And nobody will teach you about how to create your thinking skill in learning. That's why every single day I'm talking about thinking. This is what thinking. How to develop your thinking in learning. You create question. You ask yourself, what if that one from 5 just now, what if 6? That is thinking. What about 6? What happened? So can I do forward or backward case? Oh, this is not forward case, this is backward case. You on your own is asking yourself, you are answering it yourself. Can you see that?
Yes.
That is thinking. This is what required when you are working. So the machine is not working now. So what's the problem then? So you can detect the problem by asking and answering yourself. Can it be here? Cannot. Because this is half here. Or maybe here. Cannot also. Because this is also half here. So you can talk to yourself. You're not depending on other to find out. This one, people have thinking skill has. Are you with me, guys?
Yes.
This is what I want to become an engineer. This is what nobody teach you in a university now. How to develop your thinking during the learning. You can do that. Okay, can we conclude now, yeah? So that is the elastic plastic theory. Remember that? They must behave elastic and perfectly plastic behavior. So this is the simplest, not the simplest one, but one of the method we can predict the behavior of the plastic behavior there. By assuming the plastic part is constant. Okay, clear, guys?
Clear.
Clear, okay. Good luck. Next week we have test. Most of you, we are talking about this from previous semester. We have learned about the failure theory. So much we understand, right? And then we have the lockers, we have the profile. Where is the failure part? Where is the inside? Where is outside, right? Where is the failure limit? What is forward case, backward case? But we have done that the last 5 weeks, right? Not this week, right?
Yes.
And what happened? Most of you guys, if this is from my experience every semester, you can do this elastic plastic, but you forget about the failure theory. Because we have done it 5 weeks ago. Why? Because the understanding is just by memorizing. The memorizing keep faded away. Not by confidence, not by force yourself to understand. You conclude yourself. The failure theory is like that. The thick cylinder story about this one. You haven't concluded yourself. That's why you are not confident. And then when reading the thing, when you read something, what is the meaning of that question? That one is not being trained so many times. You're just familiar doing things that are familiar with you. Are you with me, guys? That's why. So can you review also your failure theory? And then conclude it. Can you also review your thick cylinder and then conclude it? Like we did just now. How do we conclude the elastic plastic bending? What do we call by forward case? What do we call by backward case? So what is that? So when you do what is that, you cover everything. Are you with me, guys?
Yes.
Please, okay, next week, good luck. Okay, the other things. Next, Sunday we have class, right?
Yes.
Can we move that class into sometime Tuesday is holiday, right?
Tuesday holiday.
I think Taipusam or what?
Oh.
Yes.
So they holiday. So I will be away this weekend in KL because my daughter getting married on the groom side, not the bride side. The bride side finished, not the groom side. So I have to be away that weekend. So can we move our class Sunday to Tuesday?
Tuesday what time?
Anytime is suitable to you because there's holiday, right? No class. So can we say that Tuesday 4 o'clock?
4 o'clock.
Can. Or in the morning. Or in the afternoon. It's much easier in the afternoon, 3 o'clock. Can we do that?
Can.
3 or 4?
3 o'clock can.
Okay, 3 o'clock. We have class that Sunday move into Tuesday. And then Wednesday we have class, right? And then Wednesday night we have test, right? So we can do a revision on that also. So you
Okay.
can ask me a question on that class. Okay, are you with me?
Yes.
So what time is it now?
What time is it now? 10:51.
Okay, we have a 10 more minutes. Can I start on the next class, on the next subject? Because we have 2 more weeks left. We have 2 more subjects, 2 more topics. Okay? We start the new topic, strain theory, energy theory. Can we start just 10 minutes, okay?
Can.
This new topic is not in your test, but will be in your final exam. Energy theory. Okay, clear?
Clear.
Okay, energy theory. What is energy theory? This is, we go back to the elastic. This is on the elastic part. And this energy theory, we're talking about the elastic part. Remember just now we have plastic. Previous that, thick cylinder, elastic. Stress strain, elastic. Correct?
Correct.
So only one part plastic, that one. And then we go back to elastic again. So what elastic? The stress is not exceeding the yield yet. All the stress are here. Okay? So what is elastic part? Okay. I have a very tough steel here. What is that steel? When I pull it, does it elongate?
Yes, elongate.
Just we cannot see by our eyes. To make it clear, what do? We pull the rubber band. We have a rubber band. You see that? When we pull it, tensile loading. Does it elongate?
Yes, elongate a lot.
When it elongate, just imagine. There's energy not inside that one.
Yes.
We are looking all the stress and strain, but in terms of energy now. They're all the same thing. When you pull it, there's stress not? Yes. There is strain not? Yes. But we are looking at stress and strain, not in terms of stress and strain, in terms of energy. Can you see that?
Yes.
When you pull it, energy is being compressed inside that one. Or we push it, to become shortened. Energy is inside that one, right? Like spring.
Yes.
So we're talking about that elastic energy. So that is axial loading. So when axial loading, how many type of loading do we have? Tengok. Tak confident. How many type of loading do we have?
4.
Why is that? Correct. 4. Why is that? Why is that? 4 type of loading. Ini yang kamu ni, it's not straightforward. Ini masalah you all belajar. Kita ada 4 type of loading saja. Nama dia P, nama dia V, nama dia moment, nama dia torsion. Ini yang menjadikan stress, ini yang menjadikan shear stress, ini yang menjadikan stress, ini yang menjadikan shear stress. The loading is only 4. Axial load, shear load, moment, torsion. Huh? Are you with me, everybody?
Yes.
This is what happened to you. You learn everything, but you don't know what is this. So, see that? When I put a load like that, axial loading, energy is being stored inside here, not? Yes. When I put a torsion there, twist, this go like that. Torsion, not?
Yes.
When I twist like that, the beam that one, if you do with your ruler can see that twisting that one. So when twist that one, when you release it, go back or not?
Go back.
So energy stored not during torsion?
Yes.
Yes. Go back with bending. Put your ruler there, ruler like that, and then bend it. Moment like that, moment like that. Bend not.
Bend.
So when you release it, go back to the original shape, right? So energy is stored not during that one?
Yes.
Yes, this is what happened with when you are do your bow, you know, anak panah tu, arrow. So that beam now is being bent like that, pull that one, being bent, energy is stored on that beam knot. When we release it, push it, the bow there. So energy is stored from the spring of that beam. Can you see that?
Yes, can see.
This is what all energy. So in torsion we have energy, in axial have energy, and bending also have energy, and also in shear loading. Shear loading is bent like that, so moment is another case. So the shear also have energy. If you don't believe me, pick a rubber band. Pick a rubber band, then you push your not rubber band, your pemadam, your rubber. Your white rubber, that one. You see that? Getah pemadam tu, small one, and then you push like that. When you push like that, what happened? This move like that, right?
Yes.
So this is what type of loading is that one?
Shearing.
Shear loading. So the shear loading also, energy is being stored there. When you release it, go back to the original shape. This is the understanding of shear loading. So the shear loading have energy, the axial also got energy, the moment have energy, the torsion also have energy. Okay? Are you with me, guys?
Yes.
So we are talking into that. So how to calculate the energy? How to calculate the energy in those four? Very simple. The formula is very simple. Energy is U by bending. The basic energy is what? Must be by bending is a moment, right? Bending moment must be the moment square. Moment square integrate into the distance. Moment square integrate into the distance, and then the two there. The other two must be the properties of the cross section and the material. So the moment must be E and I. Because what is holding the material is the I. Because my over I, the I is the cross section. Talking about the bigger the I, the bigger the cross section. And the properties is E, not the G. And then when energy is in terms of axial load P, it must be P squared dx 2, and then what is the other one? The other one must be, the P must be the E, and then the cross section must be A. Are you with me there?
Yes.
Because P over A, right? And then the cross section is the properties is modulus is the Young modulus, not the G modulus. What's the energy from torsion? Must be the torsion square dx, and then must be 2 there. And what are the cross section and properties? Must be the G and J there, not the I. Are you with me there?
Yes.
Because this is torsion must G properties, and the cross section is talking about J, not the I. And then what is the energy from the V? So must be V squared dx must be do. So the shear must be G. The cross section is not J, but the A. Are you with me there?
Yes.
Tau is equal to V over A, right? So this is how you calculate. So what is that? Integration, the loading, the 4 type of loading, where the moment, torsion, load, and shear load must be the load square. Whatever load square, let's say the moment square, integrate into the X, and then the other one must be 2. What are the cross-section properties? A moment must be the E, and the cross-section must be I, something like that. If that is torsion, the properties must be G, and the cross-section is J. Are you with me, guys?
Yes.
If that is a P, there must be the E, and the cross-section must be A. Now, why the cross-section? The cross-section we are talking about I. I is about cross-section. Diameter is about cross-section. And then the area is about cross-section. These are all the same. Are you with me now?
Yes.
This I, A, and diameter are all talking about cross-section. Only they are talking about meter. This is meter square. This is meter to the power of 4. All are the same. What is the same? Talking about cross-section. Are you with me?
Yes.
The same diameter, we can calculate the area. Yes. We can calculate the I. Yes. Or J. We can calculate. The same diameter, we can calculate J. Yes. But we are talking about that one. So can you understand now? Here, we have to finish first. Okay? So tomorrow we continue how to calculate the energy. Are you with me, guys?
Yes.
So the basic formula, integration of load square, integrate into distance over 2 properties. Okay? Okay, we continue tomorrow. Okay, Assalamualaikum.
Thank you, Doctor.
Please look at your previous test to do the exercise for your failure theory, for your thick cylinder, and for your elastic plastic bending. I give you some past year test, right? So you find also for your friend from your seniors. Okay? Thank you very much. Assalamualaikum.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.